Good morning, good afternoon, good evening, everybody. Welcome to EDA Summit. I am Sumeet, and I am the Chief Technology and Solutions Officer at Solace. Together with me in this session, I will be joined by Naveen Kola, who's the Head of Enterprise Architecture at HP. And for the next little while, we are going to be talking about cricket. We'll talk about smart lighting. We'll talk about snowblowers, and above all, event-driven architectures, event-driven methodologies, and how to begin your event-driven journey. Hope you have a good time, and let's start right there. So for those of you who are not from the subcontinent, not from Australia, England, South Africa, you may or may not know what cricket is, but it's pretty similar to baseball. It's about having a pitcher bowl a ball and hitting balls to score runs. That's about it. So if we go further about the complexities of this game called cricket, and we can argue which is better, baseball or cricket, but there's a lot that goes on every time a ball is pitched, right? You could be hitting it to score runs. It could be hitting those three little stumps to take a wicket, but a lot goes on, right? What does this have to do with event-driven architecture? All of those occurrings happening on the cricket pitch are actually events. Every ball is an event. So if you can think about that as we proceed architecturally, it would be interesting. So for me, when I started my career in the year 2000, when everybody was patching their mainframes and programs so that the doomsday can be avoided, I was actually working on a cricket portal. So my Y2K project was to build the fastest cricket scoring portal. And the actual goal was to make some money by selling merchandise. This was e-commerce back then. The project did not take off. It was a disaster. The company had to be shut down. We were ahead of our times. And my job there as a developer was to build this cricket scorecard, right? And how did we end up building it? I was presented a picture like this, where a single screen is used to capture all that complexity that I talked about. Which player, what runs did he score? Did a wicket get taken? Statistics, everything, right? And because you have to capture this 6 times every 3 to 4 minutes, because 6 balls will be bowled per over, this has to be reasonably quick. The capture has to be quick, and the screen refreshes have to be pretty quick. So one of the things that we did was the screen had to be 100% click. You don't have time to enter text, right? And building the screen up was you click through the score, and then you insert the score into a score table, right? So this ball, this was the outcome. Then the next requirements came in that, what about the statistics of the player? What about the statistics of the venue on which the game was played? And I, being a Java programmer, using EJBs and enterprise Java beans, for those of you who don't know, were the predecessors, the grandfathers of Spring. So microservices eventually was an evolution from these. So we just went and updated one table after the other, and we were going to make the fastest cricketing portal. We barely could take 10 users. The reason? The network was a massive bottleneck, right? Those were the days when disks were faster than network. And my boss comes in, taps on my shoulder, and says that, hey, Sumeet, you've got it all wrong. All you need to do, he was a database guy, you insert into this one table called TB ball by ball. That's the only table you insert the score into, and everything else, we will write triggers, which is exactly what he did. Wrote triggers, and all of these tables got updated. Essentially, that was when I realized what event-driven architecture was. Done with disks, you publish an event, and there are a lot of subscribers which are triggered as a result of that event. Agility came in as well, because when the new venue tables came in, the venue triggers got written. So fast forward 20, 21 years, where are we in our evolution? So from function and procedures from RPC calls to service-oriented architecture. Now we are all dealing with APIs, we are dealing with event streams, we are dealing with asynchronous APIs, and all of these things are helping us achieve better customer experience, better agility, and better robustness of our enterprise applications, right? So this is the EDA era. It's exciting times where those architectures have become mainstream. The whole entire event-driven space is becoming mainstream and for better responsive applications. But the question is, how do we go about this journey in today's era? Yeah, so if we take music as a leading indicator of evolution, what has changed in the past 20 years? Till about 2010, disks were faster than the network. But with the advent of 10 gig Ethernet in data centers and then 4G and 5G beyond that, we've seen network has more bandwidth, more speed than disk now, right? And hence the evolution. We used to carry our music on CD-ROMs and USB drives, and then iPod and the MP3 players came in. And now from Spotify to Tidal to Apple Music, pick your favorite service, we are all streaming our music. The event called music is traveling over the network as streams. And that's the evolution of today's event-driven architecture, distributed systems, distributed events, and we'll talk about that. So we've seen the benefits of event-driven architecture at a very high level, agility, customer experience, responsiveness. But how do you get started, right? You may have an API-first strategy. We were trained to think request reply. We were trained as software professionals to do API calls and interactions, function calls. But how about dealing with things as they happen asynchronously, responding to events? EDA is not just about tooling. It's the way you think. It's about a thought process, a culture of building applications such that each component produces and consumes events, right? EDA is strategic. So you might have a question that, how do I get started? Which project for EDA? Your projects would be your usual projects, right? Building a next generation payment system or a shopping cart. How do you start EDA? What are the tools, technologies? How do you get a quick start with tools and technologies that will be useful for your EDA journey? And then all the architecture patterns and the anti-patterns. So to solve this problem, to just orient our thought process of going about EDA, I'm going to talk about a step-by-step approach, which is the event-driven architecture methodology. So a 6+1 approach of attempting your initial EDA journey steps and maturing and scaling into that, right? It's a journey of 6+1 steps or 7 steps, the way you want to look at it. Starts with culture, awareness, intent, thinking events. So getting the mental orientation to be ready for EDA. Then we get into identifying real-time candidates, lay a foundation for event streaming, identify a pilot through which we then start adopting some of these foundation and methodology steps. Event-driven design, very important. Patterns that are useful for event-driven applications. Then we implement a quick win to get some confidence, get some practice. And from there onwards, we start to scale. We call it the snowblower methodology because, again, I work for a Canadian company, Solace, have a lot of Canadian friends. And when they looked at this methodology, they said, hey, Sumeet, this looks like a snowblower. And I did not know what a snowblower was. I live in Singapore. It just rains here. So that's what a snowblower looks like, and the snowblower methodology. So let's dive right in. So from a culture and awareness standpoint, what do you need to do? First step, is the organization mature about handling projects in an event-driven way? So you can take an assessment. You can ask yourselves the questions that, do you realize publish subscribe patterns? Have you built applications that way? Is your application, is your system decoupled, distributed? Are the lines of business prepared to operate in this manner, which is very loosely coupled, but having the ability to interface, exchange information with each other as events? Do you have stakeholder buy-in? And to solve some of these problems, you may want to excite a few people. You may want to hold town halls explaining these concepts, which I'll go through the rest of the talk, having some cool demos done probably. Some applications are inherently built event-driven, such as a mapping application or a trading platform. So using those demos as an example set. And what we are trying to do through these few weeks of discussions, brainstorming sessions, event storming sessions, sometimes they are called, we are trying to create event evangelists or event angelists. So have you matured or have you brought the team to become event angelists, right? So culture and awareness, extremely important to set your event-driven approach in motion. In other words, to unlock the value of your data, you have to set it in motion as event streams. Let's start with that culture, with that thought process, and we'll apply it to applications and architectures. Step number 2, once you've oriented yourself towards an event-driven thinking, which project should you get started with? So as per the methodology, we identify some real-time candidates. So you can interview stakeholders, you can interview your PMO office and say that, what are the in-flight projects that are going on, and make a list of them, right? Or what are the pain points in the organization which needs to be solved? So here is an example of a telco interaction I was having, where we prepared a list of the upcoming journeys which were going through digital transformation, whether it's cloud transformation or API transformation. So from order to activation, usage to charging, payment processing, resource management. So some vertical problems, and then some horizontal problems, data lake ingress and egress, cloud initiatives, IoT platform as a service, etc. So make a list of all of these things, and we'll apply some rules onto these to pick one as a pilot. Now, you have understood EDA, you have a list of candidates, real-time candidates. The next step is to think of an event streaming foundation. Now, this becomes sometimes a point of debate, that when do you bring a foundation? Now, if I said that the foundation was free, that basically sets you free for bringing the foundation in on day one. So what does that constitute? It talks, we talk about organizational alignment. So we've talked about that culture and all. A catalog of events would be needed as we go. But then the tooling is the Eventmesh, which is a network of event brokers, an event portal, a way to catalog, choreograph, design these events, something similar to an API portal. And then very importantly, event taxonomy. How is the address space? How is the metadata of your events going to look like? So let's dive a little deeper into this. So what is an event mesh? What is an event broker? An event broker is a way for you to publish and subscribe events, public and subscribe messages between producers and consumers. And when you network many of them together, remember, disk today is slower than network. You could do this various ways. There are event brokers which are log-based, which are very good for big data ingest problems. There are event brokers which are network-oriented, which are very good for microservices and event distribution because they leverage the faster network. And a three-step journey to liberate the data from your existing applications, to modernize your newer applications, and integrate them with the older ones. And then you have the alert and inform logic where third-party applications can also be integrated. So what is happening here is you may have mainframes, you may have distributed applications through adapters, or ideally through open protocols, they start to publish and subscribe events. So in our telco example, this could be your on-premise billing system, which would need orders that come that come from the modernized layer, from the API gateway layer. So an API invocation comes, and through this mesh, that new order would be streamed to your billing system, would be streamed to your network element systems. So in that order, you subscribed for voice and SMS and data and Netflix. Those events are going to be streamed onto this mesh. Some will go on-premise, some will stay in the cloud, public or private, and then some could also go to third parties, again, like a Netflix subscription. So end-to-end event streaming is enabled by the mesh, right? So if you have that foundation, it could start with something as small as an event broker on your machine, but have that foundation thought through from day one. And then on top of that mesh, what is the mechanism through which you can see the whole event taxonomy? How can you see mesh management, right? What are these brokers? Who are they talking to? What is the event catalog or the developer tools that are available to you? So together with the mesh, you would need an event portal, a way to catalog your events so that newer applications can come and consume and produce those events, right? So that's done with the event portal. So we've got the foundation taken care of. Get started, start small, because you're going to use it in the very first project. Then we come to pilot selection. So we listed all of those real-time candidates. Now we are going to look at them through these three lenses. Are any of these projects in progress? Are they in flight? Because rather than creating a brand new project or getting funding for that and waiting for that for 2 years, event-driven is an alternative way of building any project. So take a real-time project and see if you can build it the event-driven way. Also, you can look at pain points. Are there pain points such as responsiveness? So on Black Friday, the application doesn't work. Event-driven patterns are going to make it more responsive. Is there any burst handling scenario that you deal with? Are you going to go to the cloud, and are you going to and do you need to build that application in a portable manner? So those pain points are also a good lens to put this real-time candidate list through and select which project you're going to start your event-driven journey with. And lastly, opportunities for innovation. So you have this new project coming along and you want to put machine learning capabilities behind it. So having that as an event stream available to machine learning, whether it's a payment processing stream or a customer 360 stream, pick your candidates accordingly, right? So as you put your project list through these three lenses, you would be able to select a pilot. So let's say we chose the payment processor modernization as our event-driven pilot. Next comes the list of event-driven patterns. Now, this is the time-consuming part. This is the thing where you get your understanding clarified of all the various patterns. And I'm not going to go through all of those patterns, but they're well documented, various sources available where you can find information about it, various examples you will be able to uncover. But from publish, subscribe to topic choreography, event-driven microservices, Saga, eventual consistency and deferred execution, CQRS, so command query responsibility segregation, stream processing, and there are more, right? So let's look at a couple of them. So we talked about topic choreography. Now, this is fundamental to an event-driven architecture, an event-driven approach. So what is an event? What is the anatomy of an event? So think of it as a message, as a payload, which has an address, which is that event topic, metadata that describes the event, and the producer of the event would put that metadata on it. It will have headers, and again, technical reply to, if this is a request reply interaction, quality of service, etc. And then it has the payload. So since we selected that payment processor as our pilot event, I'm going through that example. So here you can see that the event has this metadata. It's a payment initiation message from the QR code channel on version 1 of the payload, originating in Singapore, and then details about my bank, so DBS Bank, it's a CASA transaction, and I'm paying for a taxi. Now, I can have consumer applications of these events. So rather than APIs, consumer applications which are saying, give me all payments that were initiated across all channels in Singapore, right? So you subscribe to that event through that metadata. And the event mesh, the foundation that we talked about, is going to take care of this routing for you, right? Similarly, on another protocol here, MQTT, we are looking for valid payments. So not initiated, but valid. So as long as the producer put that metadata along, you can subscribe to that. And then my data lake could come and say, give me all payments. And this is probably integrated over AMQP. So if you have this thought process, that's the need for the taxonomy. That's why you spend time on getting your taxonomy right at the start. So if we apply this to microservices, you send a payment initiation. The payment validator microservice here is subscribing to all Singapore initiation events. And then it's publishing the next event. So no ESB, no API broker, no REST calls between these microservices. That's the event choreography pattern of topic routing. The payment validator is now publishing a valid pay/valid/QR event. And the order validator or the payment validator, the next microservice is going to consume that, right? Similarly, if I got a big burst of these events, I can horizontally scale up by having more microservices consume that event. Talking about choreography, let's say we started to support payments in US. We have the next validator, the payment validator for the US comes in, and that starts to listen to that set of event set. Then how do I do error handling? My payment validator microservice publishes an error event, and then my error handler just subscribes to it. So you can see the agility. As long as your taxonomy is taken care of, it's just a convention. You publish to that convention, you subscribe from that convention, and you can just keep introducing these Lego blocks very, very easily. So I hope you get the idea. A subtle point is protocol interoperability. REST URLs are also /separated strings. All of these AMQP, JMS, MQTT topics are also /separated strings, and they are just being used in an interoperable manner. How do you take it from a event-driven microservices topic choreography standpoint to a hybrid multi-cloud deployment? That's your next pattern. So because we had this notion of the mesh, which is this hybrid network-oriented mesh of event brokers, we can easily move these microservices from on-premise to cloud systems. Legacy applications could connect using open standards and bridges. And we can also have, in this case, a QR code analytics application, for example, where we are queuing all the events. So that event stream coming on topics is being piped into an event queue, so that if this QR code campaign analytics component is slow, nobody else is impacted, and we just queue all the information up there. So lots of heavy patterns, and let's move on to the next one, right? So here we are looking at a pattern of like order management, where all the microservices that we talked about, they'll have their topics that they produce, the topics that they consume. And then there are certain other microservices such as cross-sell, upsell, data lake, AIML microservices who are also listening to these events, such that if you look at this process closely, and you can basically do this for every process that you have, every series of interactions between these microservices will have a synchronous path and will have an asynchronous path. And that's how you get deferred execution and eventual consistency using the mesh. So the asynchronous path should not be in line to your response path. So after you do step 1, 2, 3, 4, in this picture, after the payment processor, you send a reply back to your store, the initiator of the transaction, and all the other components will eventually get that message guaranteed by the mesh delivered to them. That's how you build responsive applications. So that was like a very quick touch on some of these event-driven patterns. What do you do with them? The intention is to get a quick win, right? A quick win, which is high visibility, high impact, because remember, the first step is you're driving culture change. You need that win to convince people to understand topics, because they've got to unlearn some of their synchronous interaction trainings, which again, all of us were trained on. So to give you another example of this very quickly, if you see an employee onboarding process, again, many a times has been built in an API or a service-oriented manner. But when an employee joins, it's a series of events that happens on the back of that joining, right? So if we break down this process into an event stream set, so the employee onboarding event comes, there is a synchronous interaction with the HR system and all the other systems from there, from IT to desk logistics to training to smart card access. These are all parallel event streams, right? And how do you model this choreography of events? You do that using the event portal. So pick your favorite tooling for the event portal. You can hand draw it, you can have a proper tool, you can use an event portal which does this choreography and the event catalog together with it. But the event portal is going to be your road to reuse for some of these events. So we got a quick win. Now, how do we scale the system? We scale it. Now, this is an example of how a bank scales their entire mesh. You can do the same thing for a telco. This could be a manufacturing company. As you can see, project by project, we started with core banking mainframe integration. We integrated with Swift, AMH. The data lakes came in, ATMs, branches, digital banking. Each of these systems are producers and consumers of events. And as your events are flowing, you can just plug and play these new applications onto the mesh using all the patterns that we talked about. So your foundation is in place, your patterns are in place, people have started to think in an event-driven manner. And how do they discover their events? They use the event portal. How do they know which producer is talking to which consumer? What's your choreography? Again, the event portal, which can discover these events by plugging into the mesh, reverse engineer it, hopefully works with all good brokers. And it can also forward engineer these events and create that microservices code as well using the AsyncAPI standard or any other standard cloud event, where you can actually publish and subscribe events. Okay. So essentially what you're trying to do is it's going to be hard because the culture change is being brought in, new patterns are being brought in, you're altering, and it's a step-by-step process. You're altering the way people will think about this architecture. But once you push it up the hill, push the pattern, push the thought process up the hill, it just snowballs from there. I've seen this story so many times. The initial phases are that, okay, you've got to align people's thinking, but once they start thinking events, that's how they're going to start thinking, and your agility and responsiveness is going to get better and better. So with that, coming back to Cricket, and I basically did this little demo to get my kids excited into programming. And what I was trying to do is to tie cricket scores. So when you see my team, there is a 6 runs being hit or a home run being hit, my smart lights go on. And the way I had to do this was I wrote a little poller with the cricket website for live scores and pushed that event into the mesh, which my smart light is subscribing to. And the reason is the cricket websites today are still not event driven. So if I go back to the old architecture where we started with, what if we built that application today such that the scorecard APIs was pushed as an event to the event broker or the mesh. The DB, in an eventual consistency manner, listens to it, and we update the DB. But then we can live stream these scores as events rather than API calls, and my entire application will be so much simpler. I will not need to poll any of these things anymore. One little thing, I don't know whether you've realized, if you look into the TV, the light actually goes on before you see the ball crossing, because the website that I was polling was faster, and the event streaming is actually happening even quicker than that live telecast. So with this, I'll hand over to the cricketer, the theme for the talk today. And Naveen, who's a dear friend of mine, he's the head of enterprise architecture at HP, and he's played domestic cricket in his early days in India. And for those of you who recognize cricket, there is a picture of Naveen next to Anil Kumble, who's considered one of the most prolific bowlers in cricketing history. So thanks a lot. Thanks for your time. And over to you, Naveen.
So today I'm going to talk about the journey that HP is going through in terms of its own transformation. But before we talk about the transformation, I would like to kind of highlight the current state, or maybe where we came from in terms of history of HP, in terms of various mergers and acquisitions, and various transformation projects that we have done in the past, I would say 20-25 years. It has created significant, I would say, technical debt. Now, of course, merger and acquisitions, and of course, in the case of HP, splits are strategic, I would say, imperative. But then the challenge for IT is, how do you really keep up with those trends and changes that happen for business reasons? And we have been successful in, I would say, most of the M&As. In some cases, we have to defer and maybe not really go through the full integration of our IT systems when we acquire a company or merge. In the case of splitting the company, we did acquire significant technical debt just to complete the project and then move on. And then, of course, we also had a lot of transformation projects, which actually created significant technical debt due to timelines, the choice of technology, etc. So the current state was that we had significant point-to-point integration and interfaces. They were both, again, most of them were bulk file-based transfer. But also in the case of when we had APIs, it was still very point-to-point, and there was very less of reuse. At the same time, we invested quite a bit on enterprise platforms and focused more around consolidation of applications. And that created this monoliths, which, of course, had its own benefits. But also, over time, we realized that it significantly slowed us down in terms of the ability to make changes, the significant cost in terms of change, as well as implementation. And of course, that also created high level of complexity in terms of managing the architecture. The decisions were very siloed in terms of data, the technology, and in terms of how we operated as a company in terms of managing those systems. Also, because of the complexity of the architecture and the way we were structured, the decisions that were made in terms of acquiring of platform software and the implementation, there was a lot of, I would say, lack of transparency, which created, I would say, duplication. And also, of course, we couldn't really govern that sprawl that happened over time. Of course, that a result of that, the pace at which we could change as well as innovate and to implement the solutions to adapt to the market conditions were significantly slower compared to our competitors. And it also were very expensive, especially around enterprise systems, where our ability to integrate or onboard our customers, partners, and suppliers were significantly, I would say, slower. Now, on the backdrop of that current state of acquiring the significant technical debt, we also had significant headwinds around the market conditions. And the company, traditionally HP, although we had many acquisitions and we had many different business models, right from digital compact, the acquiring of EDS, with HP being traditional personal systems, servers, with the diversity of portfolios, but most of them were very transactional business models. Now, with the era of gig and as well as the subscription-based models where you pay for what you use, the business models that we have been disrupted. So we are going through a transition in terms of moving from a transactional to a contractual model from, like, for instance, in our personal systems, instead of selling a PC or a laptop or a notebook, we want to provide device as a service where the company will manage the life cycle of your device, right from onboarding to managing your upgrades, patches, and then, of course, refreshes, and then, of course, monitoring your systems. So those transitions are happening not just from personal systems, but also, of course, print, where we have very successful subscription model with Instant Ink. And then, of course, the managed print services that we provide for enterprise. And then, of course, with our new 3D print business, we also have significant subscription models with how we engage with our partners. So all these subscription models will require a different way of architecture in terms of how we respond to those real-time events, because these are all connected devices where you have to, in terms of how you onboard these devices at the customer site, but also how do you monitor, and then how do you the bill, invoice, and then how do you do the customer success. So all those events have to be real-time. And also, of course, there's our, I would say, key differentiators in terms of the customer experience. So those are, I would say, business imperatives that were challenging us. But of course, with the underlying technical debt and the challenges we had with our architecture and the integration. Now, so that's where IT had to transform. Now, this is not unique to HP. There are some cyclical trend that is happening in the industry, whether it's cloud or microservices or events or DevOps. But those are the enablers that we had to adopt for us to really transform. Now, in terms of infrastructure, most of our infrastructure traditionally had been on-prem because of the consolidation that we did in the past, where we had like close to 90 different data centers worldwide. We actually consolidated into 3 data centers in US. But right at the end of that project, we realized that actually the data centers got disrupted. Now we have to move to cloud. So we are in the journey of cloud. So right now we are, of course, going to public cloud and in some cases private cloud. Same thing with architecture. We have consolidated significant, I would say, custom developed applications and ERP applications into a monolith. Now we realize that we have lost that speed and agility. So we are kind of decomposing that into different, I would say, microservices. Now, data integration, which is a heart of how we really share data within the enterprise with our partners, customers, and suppliers, but also in terms of how we integrate our applications and solutions. So those were primarily, as I mentioned, were through file transfers. Now we are moving to more of an API first and event first strategy. Now, same thing with the development process. Traditionally, from a waterfall to agile is a trend that we have implemented across all our projects. Now, anytime you use agile, you need that agility in terms of automation to be able to iterate through that delivery cycle. So DevOps is something that we are implementing in most of our projects. Now, underlying to all these trends, we also need to make sure we need to move away from a traditional project planning, execution, budgeting to a more product-centric planning, the budgeting and execution. So that's another trend that we are following. Now, all these are process and technology-related changes, but of course, it needs to underline with the people in terms of the skill set, the culture, all that has to focus more around a specific skill set to a more like a full stack developers or analysts. So So that's a trend. Then again, we are trying to adapt through some of these changes. Now, so we had to standardize again with the technical debt we have, and also the sprawl around architecture, the platforms and technologies that we had. The key thing we have to do was to standardize our reference architecture. Now, this is a sample reference architecture for integration. And so, as I mentioned in the past, we had various ways of sharing information across the enterprise, but also with our suppliers and partners and customers. Now, we standardized through this reference architecture 3 key patterns, which is through request-driven, which is mostly API first. Then we have standardized that with event-driven, which is through event brokers. And then, of course, we still need these file-based bulk transfer, so that's another pattern that we have standardized. So these are 3 key patterns that we have standardized. But then having patterns, we also need to make sure we standardize through a mediation in terms of how we authenticate and how we manage the policies, as well as in terms of the data governance and the metadata and the data quality. And also in terms of how we create the storage, in terms of whether we need a high performance storage or we have a data at rest, in terms of governance. So all those had to be standardized around this reference architecture. Right from in terms of how we pull the data out from a system of record to how the system of engagement consume that data is being standardized through this reference architecture. And of course, the whole operations aspects are also streamlined through this reference architecture. Now, so there are 3 key, I would say, pilots that I would like to highlight that we have adopted or implemented to leverage this reference architecture. The first one is where, in terms of how the customer-facing applications used to use the master data. So in this case, the data sources are the SAP S4 and which has most of our master data. So in the past, it used to be point-to-point, where every system that needed master data would call S4 directly and get that data. And then anytime the external system have to update or send a request, it used to be, again, a point-to-point. Now, with the event-driven architecture, we have changed that to bring an event broker in the middle. If you see the HP event broker in the middle, now anytime there is a new master data that gets created in S4, it publishes that event, whether it's a new product that got created, or a new price, or a new customer got created, it gets published to the event broker. And then in this case, the TechPulse, which is our Instant Ink application, consumes that event in real time, and then of course processes whatever follow-up it has to do. So this has significantly improved of course the response and the customer experience, unlike in the past. So the other use case is around order fulfillment. Now, in this case, again, if you see the picture on the top, the order fulfillment was, again, point-to-point, where in terms of how we shared information from our SAP S4 with our order status system, with the enterprise data lake, and then the B2B EDI data share with our partners. All that was done through point-to-point. And again, it obviously takes time and effort to create this point-to-point integration, but also it takes significant, I would say, effort to monitor and support these interfaces. Now we have changed that to now, again, Eventmesh, where a order shipment status is published to Eventmesh, and that basically transmits that to all the systems who are listening to that event at the same time. Obviously, it enables faster turnaround times in terms of change, but also it eliminates the tight coupling that used to have in the past. The other, I would say, the use case, which I think Sumeet also kind of talked about, is to decouple, or I would say, how we decompose our monoliths to a microservices architecture. So this is an example of an e-commerce shopping cart. So how we integrated that with our supply chain. So in this case, you see that there are different events being published from a location, payment, inventory, order, and customer. Each of these are publishing those events that are happening in their respective microservice onto the event mesh. And the event mesh is basically transmitting those events to the subscribing microservices. So this, again, significantly simplifies the architecture. It gives us the flexibility and the agility required and the speed in terms of how fast we can make the change, and then, of course, at a much reduced cost. So those were, I would say, a few changes I would say we made that kind of highlights the reference architecture that I shared. Now, so we are trying to bring all this together to standardize in terms of how we use our APIs, events, and microservices through standard catalogs and portals, where your ability to manage your lifecycle, whether it's APIs, events, or microservices, are all done through, say, common way of in terms of how you discover, how you onboard, how you monitor, and then how you govern those events or APIs or microservices.
So with that, I think thanks a lot, Naveen, and thank you very much